Hello, everyone, and welcome to the OCX Webinar Week. My name is Irina, and I'm happy to have you all with us. This week, we are celebrating the lead up to OCX 26, our flagship event happening in Brussels in April 2026. It's the place where the open collaboration community meets to connect, learn, and exchange ideas. If you haven't registered yet, you can find the link in the chat. We'd love to see you there in person. Now, I'd like to give the floor to my colleague Perry, who will be briefly presenting sponsorship opportunities at OCX. Perry, you have the floor.
Thank you, Irina. Hi, everyone. I just wanted to quickly highlight how your organization can get involved in OCX 26. We have several sponsorship opportunities available. These options will provide brand recognition, reaching over 600 professionals in many industries within the open source community. Through our 5 co-located events, you and your organization will have the opportunity to meet new and existing members of the community, including developers, decision makers, and ecosystem leaders. There will be several social activities where your team will have the opportunity to enhance existing and build new relationships with other organizations shaping the future to open technologies. We have 5 levels of sponsorship as well as several add-on opportunities. Each sponsor will benefit from visibility on site, online, and across our communication channels leading up to and during the event. Each sponsorship level includes a list of benefits. Some include a booth and/or speaking opportunities, and our higher level sponsorships, the Diamond and Platinum sponsors, will also receive additional exposure by sponsoring a specific co-located event for targeted visibility in their field at no extra cost. I'd be happy to discuss sponsorship opportunities with your organization. So please do share this opportunity with your marketing team or feel free to reach out directly. Arina will provide an email that you can reach out to. Thank you very much for your time and enjoy the rest of the webinar. Thank you.
Thank you, Perry. So now we are going straight to the webinar. So today we're joined by Arun Joseph, who will be talking about building reliable AI agents with existing enterprise assets, a gentle introduction to Eclipse LMOS. If you have any questions throughout the presentation, feel free to ask them in the chat or use Ask a Question tab. We'll go through them all together at the end of the session. And make sure to stay until the very end, because we'll be running a raffle giveaway where you can win some prizes. All right, without any further delay, Arun, over to you. You're muted.
Sorry. Hi. Hello, everyone. Thanks for the opportunity, Eclipse Foundation. And yeah, let's get to it. Yeah, I'll share my screen. I was asking prior to this, what do we have a view on the personas who join, whether you're technical, whether they're coming from a business background. I assume most of you are slightly technical at least, so I would keep it at the surface level. I would rather more talk about agents and how LMOS fits into those principles without going too deep technically. I hope that's all right. And in the meanwhile, if you have any questions, feel free to post it in the chat and I would pick it up towards the end of the presentation. All right. Let me share my screen. All right, so let me share. All right, so here is the topic for today is agents for the rest of us. So this is coming in from, not sure whether for the Apple, in the Apple moment, Steve Jobs used to say this computer for the rest of us, because it tried to simplify what the IBMs and the largest corporations were trying to build computers in a complex way. So this was taken from there. I adapted it to say agents for the rest of us in enterprises. Agents has all been the rage, and there's a lot of frameworks, tooling, and the ecosystem is exploding. It's an absolutely brilliant area to be in, and there's a lot of opportunity into developing this landscape as a disciplined software development paradigm. But at the same time, within an enterprise, the challenges are different. you have a brownfield systems, you need a lot of compliance, you need reliability, without which you cannot release any software. So how do you get to this? How do you bring in agents into your existing enterprise? And this is going to be the core theme of our talk. Introductions. Myself, Arun Joseph. I'm a co-founder of a company called Mosaic Agentic Systems. I also have founded something called as a Rhizome Foundry, which kind of champions open source as well as agentic systems in general. Previously, I was head of AI engineering for Deutsche Telekom Group, based out of Germany. And we have been on the agentic systems for a while. LMOS has been our first agentic project, which we started in 2023. And my background has been engineering, large-scale distributed systems engineering primarily, and across the globe. All right, so let's get to the topics to cover. Before dive, I would try to walk you through the main mental models that I had in trying to communicate how we think about agents, and how LMOS was derived as to cover the problem statements that we had. And in the meanwhile, also towards the end or in between, we'll be able to switch to some of the demos which we can demonstrate how agents can be built in enterprises. So the topics to cover, we'll cover agents where it is actually used, because the term and the terminology itself is kind of confusing. It can range from fully autonomous agents and unicorns and rainbows to actually something that works, which provides meaningful business results. So what are those? We'll cover that. And also the enterprise reality, as I described about Brownfield versus Greenfield, and the LMOS way, rather than we see LMOS as a particular technology stack, we refer to as the LMOS way, which was the original theme of the talk: how to leverage existing assets in your organization to build agentic applications, irrespective of the framework or tooling. All right, let's get to it. So agents at work. I'll give you at least a couple of examples in where we have put agents into production and seeing the results. First one, these are numbers derived from public domain for Deutsche Telekom while I was heading the AI engineering program there. A small group started building agentic systems to serve the customer sales and service use cases. For Deutsche Telekom Group, we started in Germany. And some of the numbers, this was from several months back, some 4.5 million conversations for sales and service use cases for customers of Deutsche Telekom in Germany. And it started to get rolled out into multiple countries. Again, the number is outdated from the publicly available information. And it was awarded recently the best telco board in Germany by Chip Magazine. So this is the business outcome which was derived. But from an industry standpoint, when we started this program, it was pitted against several of the emerging stacks on agentic bots, as well as on conversational landscape for sales and service bots. And we started to perform better, 38% at least back then in 2023, better than vendor products, because we started building something in-house, which knew how to plug it into existing systems better. And we had several presentations, which was one of the first agentic systems, at least in production, we know of in Europe in a larger enterprise. We had a talk at InfoQ last year with Patrick Will and myself about how we came up with a PaaS platform, much like the Heroku for agents, and using it to build agents that serve customers of Deutsche Telekom back then for sales and service use cases. And this was before OpenAI released their agentic framework Swamp. So we were ahead of the curve, if that's probably a light way to put it. And some of the technical outcomes that was derived, see, LMOS was not built, at least the vision was not to simply produce business results. It was built as an engine. How do you accelerate existing engineering teams to build the release velocity? Much like how we do in CNCF landscape. cloud native development landscape, right? What is your release frequency? How quickly can you build an agent? How quickly can you release an agent? And what is the cost of it? Do you need a large team, or can you leverage your existing assets? And that is not it. And ever since I moved out of Deutsche Telekom and started building my own company along with my co-founders. And we focus on large-scale operational intelligence. And one of the platforms that we build is called Atlas. And what is large-scale intelligence for operational systems? And I want to describe where we are using agents in the company that we're actually building. We actually refer to ourselves as a better version of Palantir with an open core, which allows enterprises to do operational intelligence. I'll give you an example where we are using agents for. In heavy machinery operations, if you know heavy machinery operations, for example, let's take a big crane manufacturer in Europe. And the downtime of a machine, if it's in front of at a customer site, is very costly. So we deploy our system with this customer, for example, and it's going to ingest all the data, for example, the IoT telemetry data, all the service ticket data, SOP manuals, incident history, etc., into the Atlas platform, so that it allows the operational manager of the heavy machinery operations would come in and ask, hey, we are seeing this spike of this error code, EZ473. Are they serious? Do we know what's causing it? And this is what we are building. So if you need to answer this question, you need to do a deep analysis of the telemetry data, combine it with the past history of tickets, combine it with the incident history, combine it with the machine knowledge, right? It's a very complex operation. You cannot build it as a single agent. And it comes up with results like, for example, hey, this looks like most likely the root cause because it's a probabilistic system. It cannot be 100% accurate. It's more about human augmentation rather than a decisioning system which you rely as an autonomous engine. So this is where we are actually building a lot of agents to power something like this in the background. For example, the deep analysis might come up with results like, hey, these are the two parts that need to be immediately replaced in the whole region because otherwise there will be more downtime. All of this is built with agentic paradigm as a whole. So this is what we are actually building. So we know that agents do work, but not in the way that it is advertised to be, for example, as autonomous agents, which can do unicorns and rainbows and magic. And this is what we will talk about in the rest of the talk. So what is an agent in the context of an enterprise information system? There are theoretical discussions. There are advanced research discussions like coding agent, research agent, etc. But I would narrow it down to enterprise information systems or IT systems, and then try to come up with a mental model. Before we go into agent, I would rather see agent as an agentic programming paradigm. So forget about all the business implications of an agent. Let's take programming paradigms. We have different programming paradigms, correct? Functional programming, object-oriented programming, and several such. So a traditional program, I would rather say it as it has a rigid input and a computational logic. What do I mean by that? Take a simple example. This is a chat system with a traditional program. I ask a question, find me hotels in Berlin. I made a typo. This is how we used to build microservices, right? It accepts a parameter. City name equals BRLINE. And because it's a rigid input, unless the spelling is correct, the system is not able to respond correctly. Though we can safely assume, or there is a high probability here that it's actually Berlin, right? So this is how we used to build microservices or any programming constructs, even user interfaces. It accepts rigid input. So if somebody comes up with a new requirement in in the traditional interface of booking.com, for example, I want to add a new text box, which allows customers to search for holidays. In order to implement that, you need to have a Jira ticket, a system design, a lot of implementation. But what if the system is fluid enough that at least if the APIs are available, new constructs can be created fluidly? That's how I would rather frame the agentic programming paradigm as. I also described input and computation. A program is essentially input, some computation on the input, there is output. Everything that we know of in the programming model goes like this, right? It also has rigid computation, the traditional programming paradigms. Another example, book me the King's Hotel in Berlin. Then the traditional program says you must first use the list hotels function. I was trying to use this as an example to demonstrate traditional programs execute linearly. You first have to call the list function. Only after that, you can call the booking function. This is the case, for example, you must have seen if you try to call any call center, they say, hey, first press 1, then state your name, then state your urgency, etc. What if you, in one shot you say, hey, I'm Arun, hey, my car just broke down. I need quick service. So I've described who I am, Arun. I already described what my problem is, which is my car broke down. And with this information, the program should automatically skip, ideally, the previous function calls. This is the mental model that I would use for the rest of the presentation to describe what agentic programming paradigm means. So I would describe this as an agentic program has some fluidity. That fluidity can be completely fluid. If you define the perimeter, it's fluid input and there is a fluidity in the computation. Example, this screenshot is taken from the LMOS ADL IDE, which I will show you towards the end of the presentation. The same example that I showed earlier was built as an agentic program. So I ask a question, find me the best hotel in Hamburg, and then it's calling the booking agent. It's not rigid to pick only, let's say, the best. How do you define the best, for example, right? It's able to define this as a reasoning logic, and it's able to do this querying. And as you can see, it is in fact calling two functions to the bottom, the get travel profile and call agent in here, right? So it's fluidly calling these functions to make it happen. And fluid composition, the same example. Find me the best hotel and also at the place with the warmest weather. So it's a composition of functions, as you can imagine, right? In the traditional program, you would raise it as a Jira ticket because this composition cannot be done dynamically. And then an engineer will have to pick it up and then assemble these function calls into a new widget or something, which somebody has to create. But in the agentic program, in the programming paradigm, if you're able to plug these functions, you can dynamically compose these functions. And the implications in enterprise IT systems and also in any computing systems is tremendous, because the way you are going to design your programs are going to radically change is what I would indicate. So we would use this as an example. Of course, there are advanced examples I have, but for the rest of the talk, I will ground it on here. Now let's talk about enterprise reality. If it's so simple, you'd have seen, I'm pretty sure people here must have taken different agentic frameworks for a spin, LangChain, LangGraph, etc., etc. Almost all of them try to do context engineering and wiring and plumbing. to an API call, to an LLM. This is what they do. But the enterprise reality, and we need to understand from where LMOS was born. All of enterprise IT is divided into presentation, storage, computation, and transmission, right? Any program that you take, a booking program, a booking microservice, you have a presentation layer, a computation layer, storage, and transmission, because the data need to travel to other locations. In an IT, in the brownfield enterprise is composed of hundreds of such systems. You would have, let's take a telecommunication company. You would have your product API, which is managed by one team. Then there is a catalog API. Then there is the order management API. These are all different microservices teams with their own stacks, with their own APIs and complexity. If you want to build an agent on top of all this, this is where the problem statement starts to differ in Greenfield versus Brownfield. In Greenfield, there is only a couple of people, most likely, or the program is so simple. Every engineer knows the APIs. Every engineer has first-class APIs, and they can choose whatever stack that they want to build agents. But in enterprise, these APIs are not really simple. For example, how do you build a product query agent in a telco, right? Have you seen a telecommunication API? This is an example I took from TM Forum, which is the telecommunication companies consortium, which publishes standards on how the APIs should be. I don't want you to zoom in into what was shown, but this is in fact an API of a brownfield enterprise. There are at least 100 attributes in every API, and each of these attributes means something. And in fact, it's a DSL. It's so difficult to understand what the meaning of an attribute is. For example, here there is an attribute called as subunit number. What is this? Can you feed it to an agent? How would an agent or anybody in the world would know what a subunit number is? This is where things start to crack down in an existing brownfield enterprise on wiring this domain data into those agents. Because as I said, if you want to build an agent, any agent of consequence, you need to plumb the data, right? Without that, it's a prototype. And this is where the biggest hurdle in enterprises usually start to come in. So those in enterprises, this is a picture in 1962. This guy tried to pick a car and made an airplane out of it. And in fact, it kind of flew. This is how all those who try to build enterprises feel like, at least from my experience, because it's not Greenfield. Otherwise, you could have built the shiny new F-16. But this is the reality of enterprises. You have all these traditional cars or trucks or something. The engineering ingenuity is how to plumb in the aerodynamic components and propulsion components and convert it to an agent. It's different from a greenfield place. Yeah. You'd have seen agentic workflow builders, and H10 is one good example, and also things like, not sure, OpenAI released something, right? And immediately people start to say, oh, it's so easy. Can I not go in and click here? And the poor engineer in these organizations are left wondering, why is it not? Who is going to tell them the idea that there are 150 attributes which only 5 people know what it actually means? Yeah. And this is where, and then why not pick this shiny new framework, which is in, let's say, in Python, while the entire organization is in Java? And you start to form a new team. No one knows what these APIs are. Hey, just give us the API. This will not work. This is where most of the seams start to break. So this is what I started to describe what an agent is, what it works, and the problem statement in enterprise. And if you start to pick a framework or a tooling and start to form a different team, which is detached from the existing teams, who know the domain, who know the business, who know the APIs, and you start to pick a new shiny enterprise AI program and provision models and pick the framework with the most stars and bring in vendors uh, with evaluations or many other things without knowing what you're actually building. What you have is this team starts to build something, but it does not connect to the existing systems because no one knows how to evaluate or test or plumb the data into these systems. And the actual people in organizations who know what these systems are completely detached or not being taken part of the journey. And that brings us to LMOS. So when we started in 2023, no one was actually talking about agents. At that point in time, it was only RAG. So DT's chief product officer had this vision of immediately forming a program. How do we put this technology to use? And which culminated in forming a very small team. Instead of waiting, enterprises usually wait a lot for the technology to be proven. So he started forming this team, which was a very small team. I was grateful to be part of that team in leading the engineering. So we started to see how to put AI to use, and it was the best place for sales and service use cases. But the only paradigm which existed back then was the RAG paradigm, where the idea was let's throw in all our PDFs or documents and see what comes out. It's like alchemy. But if you want to solve sales and service use cases, for example, in a telecommunication organization, you need to answer actual questions. What is my bill? Why is my bill so high? How can I change my contract? These are all business processes. You need to get deep into the system. So no paradigm existed back then. And this is exactly the place we started building LMOS. We had a vision, which so this picture shows the two legs of why LMOS was created. For example, on the real world complexity at that point in time, we had to build this for not one country. Because, for example, Deutsche Telekom is operating in 10 countries in Europe, and there are central platforms. How do you build sales and service use cases for 10 countries, which has different APIs, which has different business processes and different languages and different domains and multi-channel? You cannot pick it as a simple framework, let's say LangChain. We picked LangChain back then and started building. Our entire systems were in Java. Our engineers were in Java. We had huge investments in CNCF stack back then. And it was such a painful process to have a new Python stack, and even the abstractions were imperfect. It was because everyone was figuring out. LangChain was also figuring out. So we had that vision, but we also had a vision. I was fortunate to be part of that team because we were able to come up with a small group which included really great distributed systems engineers and open source people who thought in first principles to have a vision. What if we could create a new platform and a paradigm for agentic computing? We used to call it agentic computing. Let's build it as a layer like a Heroku, and we would be the first in the world to do this, right? So this was also the vision which led us to pick the framework and the tooling and everything, which led to what is referred to as LMOS. Why is it called LMOS? It stands for Language Models Operating System. The acronym and the mental model was we start to think about LLMs as just like microprocessors, but more intelligent microprocessors. So instead of building from on top of what we already know as a lot, but what if we start a new programming and platform paradigm which knows how to work with non-deterministic program flows? Because you're calling an LLM API. The LLM API might come back with a function name, and that function name, you need to check whether it need to be executed or not. This is a new programming paradigm, right? As against the traditional von Neumann computer paradigm where instructions are deterministic. So So the idea to champion something which could potentially be the first in the world to champion as a Heroku of our agentic computing, but grounded in solving this left side problem of plumbing into existing systems led us to create LMOS. That's the most important framing I can highlight on why LMOS existed. Now let's back into the enterprise complexity. So if you were to do that, you have hundreds of APIs in those 10 countries, and each of those countries have different business processes and engineering teams. If you start to build a completely new stack, the complexity is multiplied, but that's not the direct consequence. The complexity is a consequence of existing engineers are not able to participate in that move in that building process, right? So even if you bring Ilya Sustakar into a team and say, "Hey, build something," and I don't think he might be able to build it, not because he's the moment you show him this telco APIs and all that, well, he would ask, "Why am I doing this?" Because it should be done by people who actually know this, right? Because there are client libraries already created. And that exactly went into the LMOS principles, which is what I wanted to highlight as the LMOS way. So what is the LMOS stack? So when we used to say LMOS at one point was the greatest stack in the world, it's time to show that stack. What is that stack? This is the LMOS stack. It's not Java or Python or whatever I would rather frame it. This is why I want to frame it as the LMOS way. LMOS stack was built to cater to existing engineers in enterprises who knew the domain APIs, and they already had a lot of libraries created to how to talk to those APIs. What can we build which allows them to build agents so we absorb the hard concerns? This is the starting point. Then what tooling can we build for managing the life cycle of such programs? This is what went into the DevOps of the platform side of LMOS. Then we had an innovation on the business side, which I will talk about, which is called the Eclipse LMOS ADL, the agent definition language, which allowed business to define the agentic behavior. So, and this is precisely where LMOS comes in. On the LMOS Arc is a framework which was built in Kotlin because most of our enterprise stack were in Java. We had a lot of libraries and client libraries which knew how to connect to the product API, and the engineers knew this. So we built a stack on JVM when no one was building it back then. Spring AI was still in its infancy. I don't think even Spring AI existed back then. There was a part of LangChain to LangChain4j was emerging. So we built something which catered to our engineers because we wanted to reduce the cognitive overload. We came up with this small DSL because Kotlin allowed you to build simple DSLs. This is what we built. I won't go into the LMOS platform because there's a lot of topics to cover. I would cover the LMOS Arc a little bit and ADL and probably end this talk. A simple example of the Arc framework, this is how it kind of looks like. It's I can switch to IntelliJ. This is a DSL. This is a Kotlin script file with the existing engineers can write. And to that project, they can add their existing client libraries and immediately call the APIs. There was no MCP, there was no nothing, because you could directly plumb the API and transform it because they already know what 10 attributes do you need to extract from those 100 attributes to pass to the LLM, right? We talked about Arc framework. We'll use probably 5 more minutes to showcase the Arc framework, but the most important lever which allowed us to also move fast was not just framework innovation. Imagine in the traditional world, if you want to build in the traditional world, in the traditional programming world, you want to build a button. Someone would go into Jira, a product owner comes in, or a business comes in, says, "I want a green button which says click me," or something like that, right? And somebody picks it up and does it. How do you describe the definitions for an agent? For example, find me the hotels in Berlin. How do you cannot write a requirement like that. So we encountered this problem because a lot of time engineers would connect the data. There are instructions, there are prompts, there are evaluations. But when you start to actually put it in production, there are many variants that comes in. So what we did was, instead of going this back and forth through Jira, what if we create a higher order abstraction, which is not Kotlin, and we cannot expose the full prompt to the business people or anybody, because it can leak so much. It can pose so much security threats, as well as the behavior you cannot fully control. So we came up with an approach to reduce the variability of the prompt, but still simple enough, like a DSL for the business, which is semi-English, to write the requirements themselves and test it. What happens after that? You don't write Jira requirements to fix this and that. After the engineer wires the API, the business can go in and start to continue to do the testing and make the behavior better and better. So yeah, this was the Jira traditional approach. This was the LMOS ADL, which I talked about, business logic for the rest of us. So what ADL is? ADL is not a prompt. It takes into account, I'll show you, sorry, 36. Yeah, I'll show you how it's actually done. So it's actually not the full prompt. There is a new language which was developed, a semi language, which allows business to write this logic, and it gets compiled into tools and system prompts, which makes it pretty slick. All right, so what I would do at this point is to switch and demonstrate at least what we are referring to here. Eclipse LMOS. I would recommend, if people in this call, if you have a JVM ecosystem, or even, yeah, I would start with the JVM ecosystem. To start, forget about the platform and all the other constructs within LMOS. There is something called as the LMOS ADL. This is a good place to start to test the agent for your business use case. For example, this is how the LMOS ADL looks like. Buy a new car. You start to, just like use case that you used to write in product requirements in Jira or so, you start to write it in an IDE. That's the only difference. But there are some constructs the business needs to understand. That's all. Let's write in the playground. And this UI is actually part of the LMOS tooling. It is a simple Spring Boot application with the Arc framework. You do the git clone and then simply start the Spring Boot application. You will get this UI. And the engineer would actually, maybe I'll pick the IntelliJ, it's much easier. And the engineer would be able to wire the APIs or the data. Oh, it's not able to move it. Yeah, yeah, I'll move this one. Okay, so choose. This is the last minute presentation looks like. I'm sorry, I'm not able to move the IntelliJ pane in here. What I wanted to highlight was, you just start the Spring Boot application like this, and the engineers are able to add the libraries that they are familiar with. For example, the product API client library or other JVM libraries, and then immediately you start to write functions and wire the data, and then you have a basic agent. Once you have a basic agent, let's talk about a concrete example. Let's say you're Volkswagen or some automobile company, and your business wants to build an agent which helps your customers to book an appointment. The process is the engineer would actually start the application, the Spring Boot application, which I referred to as LMOS Arc, and they would get and they would wire the APIs or even mock, and then they would get a UI like this. You can already try it from the ADL page. There is a try playground, and let's talk about how it actually works. You remember your engineer built it. It's not some black box. You're able to wire your APIs. You don't need MCP. If you have an MCP, of course, you can connect MCP, but you start simple. That's the whole idea. And let's say if you want to create a business process, a logic, you would go into this section called ADL. You go into the automobile. I have an automobile example already created. Otherwise, the creation would look like this. I can go in here and click in here, and I would start to create my ADL. This is the business process. And what do you write in an ADL? Remember, it's written by the business person. It will look like this. For example, book the service appointment with Volkswagen. There are a few keywords the business person need to understand. This is a semi-DSL part we talked about, because we have a compiler which knows how to process these things and not send it exactly as it is to the prompt. So the business process in booking in a specific company like that is really complex, right? It's not like simple book a hotel. For example, in here, if the date is available, do this. If the customer insists on an unavailable date, escalate to a human advisor. And there is a construct called solution, fallback solution, etc. I would recommend you to go through the documentation, but the key takeaway here is it allows a simple way for the business to define it and immediately test it. Meaning the business would come in here, they would choose an agent like this, for example. This is the UI that will greet them. So if your engineer has built it, they can stand it up in your company's intranet, and you inform the business person, hey, it's ready. I have connected the data. Now you can continue iterating and making the agent better. The business person would go and create the ADL for that use case, like how I showed you. Then they would pick the ADL, in this case, automobile example. If there are tools, forget about tools, but let's see how it actually works. So now the business person is asking, hey, my Volkswagen just broke down. Need assistance. Based on and it's actually a place to actually test and see what is going on. So the business, depending on if you're an engineer, you need to know which functions were called, which is the hallucination detector, and a lot of other things are here. But if you're a business person, you come in and see whether you have the proper business functions loaded. So it classified this question as ambiguous question because in the ADL, it's you have defined a use case called as an ambiguous question, right? So you start to break the big problem into something smaller. And then you continue asking, what kind of assistance do you need? Yeah, I need roadside assistance, etc. Yeah, so this is exactly how it was programmed, because you do not want to have, roadside assistance immediately made available was a use case which was added. So, but if you were to say, my car is making weird sounds, need an appointment, let's say golf. And then it starts to go into the actual flow. Here, it is not ambiguous. You see, it's actually picking up the right. So this is a way for the business to actually see what is going on. And if it's not working, the behavior is not correct, they would go in, edit the ADL, come back here, iterate faster without reaching out to the engineer. There is no Jira and all that, right? And I say, hey, it's Arun. Hey, it's my name is Arun. I have BN1234. It's asking for your for the date and tomorrow, etc. So let's see if it actually works. As you can see, the business person is also able to see what are the functions which were called. In this case, it started to call the book appointment, check availability, send confirmation. All of it was called. The business person, the engineer wired the data. Even you can go and create mock tools. You don't need to actually think about MCP and all that. That comes in at a later stage. You need to first prove whether it actually works. And this is how the development process is accelerated with OCDL. Yeah. So that's ADL, and I would pick this up. And yeah, that's essentially it. So there is also, I would open up for questions, and you can already tie ADL in here. And there's also another project called AGC, which is for large scale agentic creation, agentic applications. And yeah, that's essentially it. Open for questions. Thank you.
Thank you so much, Arun, for this great presentation. In fact, we already have a few questions from the audience, so I will put them on the screen and we'll also read them for you just in case. So the first question: how do you define meaningful progress toward artificial general intelligence in a way that's measurable today without falling into the trap of over-promising or building narrow models?
That's a good question. So I would frame it as this, yeah. And there are two parts to it, because this is where the confusion actually comes in, at least in my mental model. There is research, there is the theory, which is the aspiration. How do we get to Mars? How do we get to immortality and all that? Then there is a research for that. Then there is a practical application of agent or whatever it is called. I would frame this question on the research side on AGI, because the definition for AGI itself is moving so fast, if I understood the question correctly. The idea that we are not, the question that whether models alone is enough, for example, this is the first question to ask. And essentially, the world is a malleable place and a moving place, the entropy, and because it's not static, right? So if you build AGI for today, the definition of AGI itself is continually learning, right? How do you build something like that? This is also the case, this minuscule version of that you can apply to a simple agent you create. It's not the service booking appointment for today. How can it continually learn with your new business processes? At the last stage is autonomous. You just connect to your systems, it automatically understands the business process has changed. This is the way I would frame it. Meaningful is a big word, as it's one of my favorite words. So I try to focus myself into how do I make it useful today, because there's a lot of debate around what is AGI, what is meaningful, and all that. Yeah. Thank you. Thank you for the question, Thomas.
And we have one more coming in. Just 1 second. So another question. From your experience, what's the biggest architectural barrier preventing enterprises from integrating generative or autonomous AI agents into their existing systems at scale?
Yeah, this is a good question as well. Point number one is what I described in the presentation. The biggest architectural barrier, I wouldn't call it barrier. It's at this point, most of the thing is breaking down in the way it is being approached. For example, enterprises think that you can only build agents with a completely new team and a completely new stack, and you need models. So there is a lot of lack of understanding what is required to build an agent. What if all of that is just noise? What if it could be created by your existing teams? Uh, then all the architectural principles that we have learned over the years, it's not going away. It's just that the acceleration, the measurement loop comes in. At least majority of the programs that fail, in my view, fall into the category either they are over engineering or going after something which was not even needed. Second, there is no clear definition of what are you trying to accomplish with this. Is it reduction in this? There's no clear metric or improvement approaches.
Perfect. Thank you so much, Arun. I don't see any more questions at the moment, but we can give a few more minutes to everyone to think a little bit, and we will do the raffle for now. So let me share the screen. So I added all the participants to our raffle website. I think you should be able to see the screen at the moment. So the person who will get the first place will get a free OCX 2026 ticket, and second and third place are €50 OCX workshop vouchers. So let's start. There will be a 10 seconds countdown. There you go.
I thought I would get one just simply by presenting.
You will get something, don't worry about it, but this is a separate thing.
I was just joking, of course. Yeah.
So we see the winners now. The first place is Kellen. So you're getting a free OCX 2026 ticket, and Kaloyan and user 1437, many numbers. Please don't test my English here. Gets €50 OCX workshop vouchers. So we will contact you separately. You will receive emails from us. So I will stop sharing the screen for now. We can check if they have any more questions. Let's see. It doesn't look like it, I think. So thank you so much, Arun. We really appreciate you joining us and sharing this presentation, and we hope to see you at the future webinars. Congratulations to our winners, and I wish everyone a great rest of the day.
Thank you, everyone, for joining. Feel free to reach out through GitHub or anything to if you have any further questions. And thanks for the opportunity. Pleasure.
Thank you so much, Arun.
Even though I made the presentation in the last 15 minutes, so excuse the poor slides.